Hello guys, welcome back to my YouTube channel. Myself Rakshit. Today I am going to presenting on introduction to recording rain gauges. First we'll move on to introduction to recording rain gauges. Recording rain gauges are vital instruments used to measure and record the amount of precipitation over a set of period. They provide detailed data necessary for various applications from agriculture to hydrology and climate research. Definition and purpose of recording rain gauges. Measurement accuracy. Recording rain gauges are designed to accurately measure and record the exact amount of rainfall, providing precise data for analysis and forecasting. Long-term data collection. They are used to collect and store historical data on precipitation, enabling the study of long-term trends and patterns. Environmental monitoring. These gauges contribute to environmental monitoring efforts, helping to assess the impact of precipitation on ecosystem and urban areas. Type 1. Tipping bucket rain gauge. Functionality. The tipping bucket rain gauge uses a mechanism that tips when a specific volume of water is collected, recording each tip as a unit of rainfall. Calibration. These gauges are carefully calibrated to ensure accurate measurement and to account for potential environment factors that may influence readings. Notable applications. Commonly used in weather stations, research facilities, and agricultural settings for accurate real-time rainfall measurements. How a tipping bucket rain gauge works. Internal mechanism. The gauge features a funnel gathering rainwater which fills a small bucket until it tips, recording the specific amount of precipitation. Electronic recording. Recorded tips are electronically logged, making it convenient to extract and analyze the data for various scientific and practical purposes. Low maintenance. Requires minimal maintenance and adjustments due to its steady construction. Advantages and limitations of tipping bucket rain gauges. Advantages: high precision, real-time data recording, reliable performance. Limitations: susceptible to clogging, limitations to intense precipitation events, requires regular maintenance. Type 2. Weighing rain gauges. Measurement principle. Weighing rain gauges operate by measuring the weight of rainfall collected in a defined area, offering highly accurate rainfall measurement. Automated data collection. They are equipped with automated data logging system, allowing convenient access to real-time and historical precipitation data. Application flexibility. These gauges are used in agricultural research, urban hydrology, and environmental impact assessments due to their precision and reliability. How a weighing rain gauge works. Weight measured. Rainfall is collected in a container and the weight is continuously measured, providing accurate rainfall database on the increase in weight. Integrated sensors. Equipped with sophisticated sensors and data processing units to ensure precise and reliable recordings of precipitation levels. Maintenance considerations. Regular calibration and maintenance are essential to ensure the accuracy and consistency of measurements over time. Advantages and limitations of weighing rain gauges. Advantages: high accuracy, real-time data collection, low maintenance. Limitations: it requires calibrations, initial investment cost, complex installation process. Type 3: Optical rain gauge. Principle of operation. Optical rain gauges are use light sensors to detect raindrops, providing immediate and accurate data on rainfall intensity and distribution. Environmental integration. These gauges are integrated into urban and environment monitoring system for real-time data on precipitation for efficient urban planning and infrastructure management. Potential applications: widely utilized in meteorological observation networks, transportation system, and urban water management for precise rainfall monitoring. How an optical rain gauge works. Light sensors. Advanced light sensors detect raindrops passing through the detection area, providing immediate data on the quantity and intensity of rainfall. Data transmission. The collected data is transmitted in real time to monitor systems, allowing for prompt decision making in response to changing rainfall conditions. Integration capabilities. These gauges can be integrated into smart city infrastructure, supporting efforts in disasters management and efficient resources allocations. Thank you guys. Thank you for watching my video. Please do like, share and subscribe to my YouTube channel.